All right, number one, it's asking us to do f of x plus g of x. So f of x is 3x squared plus 7x. To that, they're wanting us to add g of x, which is 2x squared minus x minus 1. When we're adding, all we do is combine like terms. So 3x squared and 2x squared are like terms, so together they make 5x squared. 7x and negative x are like terms. 7 minus 1, that's 6, so that's 6x. And then for a constant, all I have is the minus 1. So 5x squared plus 6x minus 1. Number 2, we're subtracting. So f of x first. From that, subtract the g of x. Since it's subtraction, I'm going to change that subtraction to addition and distribute the negative. So I'm making the subtraction positive, distribute the negative throughout the next set of parentheses. The 2x squared becomes negative then. The negative x becomes positive. The negative 1 becomes positive. So now combine like terms, a 3x squared and a negative 2x squared. 3 and negative 2 make 1, so that's 1x squared, or just x squared. 7x and a positive x, that makes 8x. And then a positive 1. So 7x squared, or sorry, x squared plus 8x plus 1 is our answer. Now number 3, we multiply. f of x times g of x. Becomes like a distribution problem. Take the 3x squared and distribute it. So 3x squared times 2x squared becomes 6x to the 4th. 3x squared times negative x becomes negative 3x to the 3rd. 3x squared times negative 1 becomes negative 3x squared. Then distribute the 7x. 7x times 2x squared is 14x to the 3rd. 7x times negative x is negative 7x squared. And 7x times negative 1 is negative 7x. Combine like terms, 6x to the 4th. And then we have a negative 3x to the 3rd and a 14x to the 3rd. So that's a total of 11x to the 3rd. Negative 3x squared and negative 7x squared, that's negative 10x squared. And lastly, I have minus 7x. Number 4, f of x over g of x. F of x is 3x squared plus 7x over the g of x, which is 2x squared minus x minus 1. If you're coming to me from a different teacher, notice it says indicate any restrictions on the domain and range. Some of the teachers talked about doing the fact that denominator can't equal 0 and solving to figure out what those values would be. I'm just stopping at this point. I'm not asking you to do that piece of it. Not that you're not able to, but I want to use our time and attention on other parts. So I'm going to just leave it like that. Once you get your fraction, you're done. Now number 5, f of g of x. So f of, well, g of x is x minus 6. So I have to plug that into the f. What is f? Well, it says x, but that's where we plug in what's in our parentheses. And it says to square it and then add 2. When you square x minus 6, you have to, unfortunately, you have to take x minus 6 times x minus 6. And then add 2. And you have to FOIL x minus 6 times x minus 6. So you get x squared minus 6x. Then you get negative 6x times positive 36. And then at the end we have our plus 2. Combine like terms, we have x squared. Negative 6x and negative 6x makes negative 12x. And then 36 and 2 makes a 38. So x squared minus 12x plus 38 is our answer. Now when we go the other way around, g of, and f of x is x squared plus 2, so plug that into the g. The g says, where it says x, that's where you plug in. It says to take that minus 6. Here there's no squaring to do, just combine like terms. So x squared and then 2 minus 6 is negative 4. So x squared minus 4 is our answer. Number 7, find the inverse. That's where you switch out the x and the y. So it starts off with x equals 3y minus 1, and you want to solve that for y. So we would add 1 to both sides. So over here you have x plus 1. On the other side you're left with just 3y. So then we divide by the 3. Get y by itself, so what does y equal? Well, it's x plus 1 all over 3. Done. Number 8, switch out the x and the y. X equals y squared plus 3. So I would subtract 3 first from x, giving us x minus 3 equals y squared. To get rid of the square, we have to square root, and anytime we square it, we have to do plus minus. So we get y by itself equals plus minus, and then you have the square root of x minus 3. There's your answers. Number 9, determine if they're inverse functions. So to do that, we have to first take f of g of x. We're checking to see if it equals x. So g of x is 4x minus 20. So I plug that into the f. So f says take 1/4 times, and then in place of the x we're going to plug in 4x minus 20, and then you have plus 5. So distribute the 1/4. 1/4 times 4x, that's just x. 1/4 times negative 20, that's negative 5. And then at the end I have plus 5. Negative 5 plus 5, those cancel, leaving us with just x. I'm going to put a check mark there because it worked. It equaled just x. Since that worked, let's continue on. There is still potential for them to be inverses. If that didn't equal x, I would have stopped and just said no. They're not inverses, but it worked. So now I try the other way around. G of f of x, so, which is 1/4 x plus 5. Plug that into the g. So 4 times something minus 20, plug the something in, 1/4 x plus 5. Distribute the 4. 4 times 1/4 x is just x. 4 times 5 is 20, and then from there we subtract 20, that equals just x. Put another check mark, and it worked. Both of them worked. So they're asked us to determine if they're inverses. Yes. We'll just say yes, they're inverses, or we'll say inverses. But they worked. Number 10, domain. Let's see, we've got x. And the smallest thing we can plug in, we could only have a 0 in there. If you plug in 0, you get that. We don't have an h in there. So x has to be greater than or equal to 0. For a range, there's no k, there's no shift up and down. It is positive in front of it, so it's going to be y is greater than or equal to the k, which is 0. Table of values, you can use a graphing calculator to help you with these. So I've got to be careful, I guess, on what I pick to plug in. So I'll plug in 0 first. 2 times 0 is 0. Square root of 0 is 0. Now, I want the number inside to become a perfect square, like 1. I'd like it to become a 1. In order to get 2x equal 1, x has to be 1/2. If I plug in 1/2, 2 times 1/2 is 1. Square root of 1 is 1. I get a nice answer. The next number that would be nice to get is a 4. You have x. In order for that to happen, x has to be 2. 2 times 2 is 4, and square root of 4 is 2. And then if I want x to be 9, or if I want 2x to equal 9, because 9 is a perfect square, so x has to be 9/2, or 4.5. So 4.5 times 2, that's 9. Square root of 9 is 3. So those ordered pairs are going to work out nicely. 1, 2, 3, 4.5. Connect the dots. Remember that the left side is just an endpoint, so don't go through it. It's a point there, but it goes to the right. Number 11. Now we've got an h. We have to switch signs, so h is a positive 3. There's still no number at the end, so k is 0. So our domain, x is greater than or equal to our h value, which is 3. Our range, y it is positive a, so it's opening up, so greater than or equal to whatever our k is, which is 0. You can also plug this in the graphing calculator again. But the first number I can plug in is 3. So 3, 0. My hk is going to be my first order pair. And then I plug in 4, because that's going to work out nicely. 4 minus 3 is 1. Square root of 1 is 1. Times 2 is 2. The next number that's nice to plug in, I'd like to get a 4 in there, so that has to be a 7. 7 minus 3 is 4. Square root of 4 is 2. Times 2 is 4. The next number that's nice to square root is a 9. To make a 9 happen, this has to be a 12, because 12 minus 3 is 9. So I can try 12. Now I think that goes off my graph, so I probably won't even graph it. But 9 square root of 9 is 3 times 2 is 6. Okay, let's see what we can graph. 3, 0, 4, 2, 7, 4, and then we get off the graph. So I'm going to just graph those. There's my picture. Back page. This is a square root. I know it's not zoomed in real close, but you have it in front of you. If it's a square root, we don't have to put a number there, but they did. A square root of a negative, we're not allowed to have a negative in there unless we have an I. So we know to deal with the negative. We're going to we can kind of break. Oops, sorry, I didn't mean to put. We can kind of break the negative 1 square root of negative apart from the rest of the number 343. And now I can deal with 343. Well, 343, if you do a factor tree, it's divisible by 7 49 times. And 49 goes to 7 and 7. So we get a bunch of 7s. So I have a pair of 7s, so I get to pull 7 out. But I'm going to have a 7 left inside. And this I, the square root of negative 1 becomes an I. That goes in front of the square root, but after the 7. We like to put the number first, then the imaginary, then the square root last. So there's our answer. Number 13. That 4 might be helpful to think of 4 as 2 squared, or you could have done a factor tree. There's no number there, so we know it's a square root again. We're looking for pairs. There's a pair of 2, so that becomes just a 2. And then there's 10 A's. I'm looking for pairs. That means there's 5 pairs, and then there's none left over. So there's my answer. No square root left. Number 14. There's a negative in front of the problem, so it's going to stay there. Okay, we have 6 M's. We're looking for 3 of a kind. So there's 2 3 of a kinds in there. So we get to pull out M twice. As far as N, there's 9 in there, and looking for 3 of a kinds. That happens 3 times with none left over. So none inside of a third root. Number 15. Simplify. Well, we could do a factor tree on 54. 2 and 27. 3 and 9. 9 goes to 3 and 3. So I do have a pair of 3's. So I already had a 5 out front. Now I pull a 3 out. What's left? There's a 2 and a 3 that weren't paired. They're stuck inside the square root. So 5 times 3 is 15. 2 times 3 is 6. I get 15 squared of 6. Number 16. I've got a 98. It might be helpful to think of 98 like a factor tree type of deal. 2, 49 goes to 7 and 7. So I have a pair of 7's there. So that denominator, I'm thinking of the numerator and denominator separately. So the denominator I get to pull a 7 out, but there's a 2 that's still inside of the square root. I'm not really worried about the numerator for a second. I know we've got stuff that can come out there, but ultimately, since the denominator can't have a square root in it, I have to multiply to fix that. There is a single 2 there. So if I bring in another 2, then there'll be 2 of them and I can simplify. So I've got to multiply by a square root of 2. In the numerator, I've got a 2, an a to the 6th, a b to the 3rd. In the denominator, I have 7, and then square root of 2 times square root of 2 is square root of 4. But that becomes just 2. So 7 times 2 is 14. I have a denominator of 14. In the numerator, let's deal with the a's, because I'm going to have a 2 stuck inside the square root. But I can pull out a 3 times. I can pull out b once. So what's inside? There's a 2 left over and a b left over. And that's all. So a to the 3rd b times the square root of 2b all over 14. That's our answer. Number 17. I can't factor tree 2, but I can factor tree 50 and 8 both. So let's do that. So first one stays 3 squared of 2 plus. Now I pull out a 5. There's a 2 still in there. And then it says minus. Now I've already got a 4 in front. So when I pull out a 2 times the 4 that's already there, 4 times 2, that's an 8. And there's a 2 left in there. So now they're all square roots of 2, so they can combine. 3 of them and 5 of them makes 8. There's 8 square root of 2 minus 8 square root of 2. Oh, they're all gone now, so now it's just as big, 0. Number 18, we've got to distribute. 2 square root of 3 times square root of 15, we get 2. And the square root of 13 times square root of 3 times square root of 15 is square root of 45. And then let's finish distributing, then I'll factor 3. 2 square root of 3 times square root of 60. We get a 2. Square root of 3 times square root of 60 is square root of 180. Let's factor tree both of these things, see what we get. 5 times 9, 3 times 3. So I get a pair of 3s, there's already a 2 out front. Pull out a 3 times the 2, that's a 6. And the 5 is stuck inside there. Plus, I have a pair of 3s. Kind of a pair of 2s and a 5 left over. There's already a 2 out front. 2, and then I pull out a 3. 2 times 3 is 6. Pull out another 2. 6 times 2 is 12. Ultimately, I have a 12 out front there, and inside I have a square root of 5. Now look, they're both square roots of 5, so they can combine 6 of them plus 12 of them makes a total of 18 of them, 18 square roots of 5. 19 is a FOIL problem. 2 times 4 is 8. 2 times square root of 7 is 2 square root of 7. Then 3 square root of 7 times 4, that's a 12 square root of 7. You only multiply the square root parts together, and the non-square root parts multiply together. And so then lastly, 3 square root of 7 times the square root of 7, that's 3 square root of 7 times 7 is 49. But that 49, square root of 49 is 7. That really ultimately becomes 3 times just a 7, which is 21. So I can think of that as plus 21. So the 8 and the 21 are like terms combined to make a 29. 2 square roots of 7 and 12 square roots of 7 make 14 square roots of 7. So 29 plus 14 square roots of 7. Number 20. I have to multiply. It says 2 minus the square root of 2, so I'm going to multiply by 2 plus the square root of 2. To both the top and the bottom. And we have to FOIL. 4 times 2 is 8. 4 times square root of 2 is 4, square root of 2. Square root of 2 times 2 is a 2 square root of 2. Square root of 2 times square root of 2 is the square root of 4, which turns into just 2. The denominator. 2 times 2 is 4. 2 times square root of 2 is 2 square root of 2. Negative square root of 2 times 2 is negative 2 square root of 2. Negative square root of 2 times positive square root of 2 is negative square root of 4, which turns into just negative 2. Combine the like terms on the top. 8 plus 2 is 10. 4 square roots of 2 and 2 square root of 2 makes a total of 6 square roots of 2. In the bottom, 4 minus 2 is 2. 2 square root of 2, negative 2 square root of 2. They cancel out, they make a 0. So I'm left with this. Now really, I can simplify this. We don't pay attention to the 2 inside the square. We do look at the number in front of it, which in this case is a 6. We look at the number over here, which is a 10. We look at the number in the bottom, is 2. Can we divide all of them by the same number? Well, yes, they're all divisible by 2. 10 divided by 2 is 5. 6 divided by 2 is 3. 2 divided by 2 is 1. So we end up with 5 plus 3 square roots of 2 all over 1. Since it's over 1, I don't have to write it as a fraction. So just 5 plus 3 square roots of 2.